Hey everyone, today is 10.2 vectors. Hopefully this will all be really familiar to you and it's going to be mostly a review. So let's see if we can speed right through it. So we're going to review how to find the component form of a vector, magnitude using magnitude and angle measure. We're going to find the angle between two vectors and we're going to find unit vectors that are tangent and normal to a curve. So that part's maybe a little bit new. We'll see. Okay, so let me just remind you of these types of problems from last year, where you are given the ground speed and the direction of an airplane using that bearing method, and you want to figure out the actual speed and or direction of the airplane. This is something we did with vectors last year, and we're going to look at them again this year. Okay, so here is like even a warm up. Let me just remind you that we have a couple ways of writing vectors. So one of them is called component form, which is just when we use the little kind of brackety parentheses. And the other one is called I and J form, which obviously has I's and J's. They mean the same thing. They're interchangeable. It doesn't really matter unless the directions tell you what you're supposed to do. And then let me remind you that something written like this last year, our book actually used the double little lines like that to signify magnitude. Um, for some reason, our pre-calc book did it this way, and now this year you're going to see it like this. Know that they're interchangeable. I don't really care how you do it. But let me remind you that magnitude is literally the length of the vector. Okay, so to find the length, you're thinking of this as like Pythagorean theorem. So a quick little review of vectors. So the vector u is 1 comma 2, so it's like this. So it's this directed line segment like that. So you want the length of that vector, which you could just think of it as Pythagorean theorem, but you're really just doing 1 squared plus 2 squared, and the square root of that is 5. And then the magnitude of v would be the square root of 3 squared plus 1 squared. So 9 plus 1 is 10. Okay, so a couple of things to remind you about with vectors. So vectors are equal if they have the same magnitude and direction. Parallel vectors have the same slope, which is really the same as saying direction. Okay, so they're going to go in the same like I and J direction, but they could be shorter or longer. And here's what I just kind of mentioned about component form. So the component form of a vector is this. When the initial point starts at 0, 0, and then the terminal point or the ending point is v1 comma v2. It's literally adjusted in the warm-up. All right, so we're going to create some vectors. So I'm going to create the vector pq. So find the component form and the length of the vector whose initial point is -3, 4, and the terminal point is -5, comma 2. So to do that, I just have to subtract the x coordinates or the j component parts and subtract the j components. I just said j twice, I first and then j. So I am going to do negative, since we're starting at p, I'm going to start with the q and subtract. So we're going to have -5 minus a -3, which is -2. And 2 minus 4 is also a -2. So the initial point, if it helps you, you can even draw the graph, right? So if the initial point is at -3, 4, didn't make my graph big enough. And the terminal point is at -5, 2. So this graph would be what we'd be looking at. This is the vector here, but if it's going to start at the origin, it has to go this way. So it's going to the left and down. So they're the same vector, we've just shifted it over. So that's why it's -2, -2. All right, and then we want the magnitude of that or the length of it. So that's the square root of 2 squared plus 2 squared, which will be 8. Okay, moving on. Find the component form of a vector of length 4. So the magnitude is 4. So I'm going to call this vector u. And the magnitude of u is 4. And it makes a -45-degree angle with the positive x-axis. So that is here. So the angle is the -45 is this way. And there's a variety of ways for you to do this. So I kind of like to think of it almost as a polar question where if the length were 1, it would be on the unit circle, and the coordinates on the unit circle at that spot are positive, sorry, √2/2, comma negative √2/2. But I want it to have a length or magnitude of 4. So I'm going to multiply it by 4, and this simplifies to 2√2, comma negative 2√2. Okay. Okay, moving on. So now I've got 3 points, and I have 4 points, and I want to create two vectors and show that they are equal. So I want to find AB. So vector AB will be 3, comma 4, because I'm subtracting 0 from 3 and 0 from 4. And vector CD is equal to -1 minus a -4 is 3, and 6 minus 2 is 4. So literally the same vector. Hopefully not too difficult. As you can see, we're just going to keep plugging along. All right, next one. Express a vector with a magnitude of 5 that makes a 30-degree angle with the x-axis. Now we're going to do in terms of I and j. So I did a problem like this already. I'm going to remind you of the other way to do it, but I'm still going to do it the previous way as well. So here's my 30 degrees. And if this were on the unit circle, then the coordinates at 30 degrees are √3/2, comma a half. But I want the length to be 5. So this would actually be 5 times this point, and it's going to be 5√3/2I plus 5/2j. And the other way we learned it was to use cosines and sines. So you could do cosine, well, let me give a little more space for this. So you could do the magnitude of the vector out front times cosine theta I plus sine theta j. So this formula works really well when your angle is not on the unit circle, but it also works on the unit circle as well. So my magnitude is 5, my angle is 30, and then you're just finding sine and cosine of 30. So cosine of 30 is square root of 3/2, just like we said. Well, I said it, hopefully you were listening. And 5/2j. Okay. All right, moving on. So we're going to just kind of jump into doing vector operations, but if you don't remember what the operations and the properties of vectors are, there's a couple pages in your textbook you can use. You can also Google it. There's tons of stuff out there. Really, it should be, I hope, like intuitive to you as you're doing things just with the x's and the y's. So I'm going to add u plus v. I'm literally going to get the vector 1 plus 3 is 4, and 2 plus 1 is 3, and that is my vector of u plus v. U minus v will be 1 minus 3 is a -2, and 2 minus 1 is 1, and that's my vector of u minus v. And then I have to multiply u by 2 and then add it to v. So 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 1 is 5. So this vector is 5, comma 5. Okay, last thing I believe here. So now I'm going to remind you what dot product is and then what we use dot product for. So the dot product is when you're multiplying two vectors together. So u dot v. And all you have to do, hopefully you remember this, is you have to multiply the I components or the x portions together. So u1 times v1 plus, then it'll be u2 times v2. And this will be what we call a scalar because you're just going to get a number. You're not going to get another vector out of this, okay? Okay, we use this a lot to find the angle between two vectors, and the angle between two vectors, which is theta here in this formula, is equal to the dot product of the two vectors that you're dealing with divided by the magnitude of each of the vectors, and then the magnitudes multiplied together. So again, hopefully this formula looks familiar to you. So we're going to use this to find an angle that is in between a couple of line segments of a triangle. So I'm going to go ahead and draw a quick grid. Actually get a line. There we go. Draw a quick grid. And then we will just figure out what angle we're looking for. Okay, so I've got the points. A is at 0, 0. B is at 3, 5. Whoa, that's bad news. See if this is any better. A little bit. 3, 1, 2, 3, 4, 5. So there's B, and C is at 5, 2, 3, 4, 5, 1, 2. This is, I'm sure, going to look terrible, but so I want the angle gamma, which is going to be related to angle C. So I actually want angle C. So that means I need to find two vectors, vector CA and vector CB. So CA is actually equal to, let's see, -5. I'm struggling today. CA, look at me, I'm looking in the wrong direction. I looked at CB, -5, -2. And I need CB, which will be 2, -3. And I need to do the dot product of those two vectors. I'm going to call this U. I'm going to call this V. So that will be U dotted with V will be -10 plus 6, which equals -4. And I need the magnitude of each of those. So the magnitude of this one is the square root of 29. And then the magnitude of V is the square root of 9 plus 4 is 13. So cosine of gamma will be -4 over the square root of 29 times the square root of 13. That the angle is equal to 101.889 degrees. All right, we have, I guess, 2 more problems. I thought we were almost done here. Close. So this one says find unit vectors tangent and normal to the curve. So I'm going to start by taking the derivative of x with respect to t and the derivative of y with respect to t. So dx dt is a half. dy dt becomes a 1 over 2 square root of t. And that means that dy dx will be equal to 1 over 2 root t over a half, which is just 1 over root t. And I want to evaluate this when t equals 4, according to the problem. So that gives me 1 over 2. So my slope is 1 over 2. Okay, so then we want to find the unit vectors that go along with this. Sometimes I find that it helps if I look at this visually. You certainly do not have to, but I kind of like it. So I'm going to actually draw what this means. Okay, so I actually have, let's just draw this vector that this 1/2 actually creates. So when I have a slope of a half, that's kind of the same as writing the vector 2, 1. So this is my change in y over change in x. So then I can graph this 2, 1. So this is the vector we're talking about. And I can find the magnitude of this. The magnitude of this is the square root of 5, which means the unit vectors that I'm looking at will be the one that I have here already, but divided by root 5. So 2 over root 5, 1 over root 5. So this would be the one that is tangent because that's what the derivative is giving me. And then I have to think of opposite reciprocal slope to come up with my normal vector. So this is my tangent. So my normal is the same as saying I could write it as 1, -2. I could write it as -1, +2. It doesn't really matter. But then I need to create the unit vector that goes with it, which is 1 over root 5 and -2 over root 5. Okay. All right. Last problem, hopefully. All right. So we're going to go ahead and do one of these fun problems. It is going to be done with vectors, just like last year. And hopefully you remember how it works. If not, this will be a quick little review because this shouldn't take too long. So I'm going to start with this grid here, and it says that the plane, lost my pen, here it is, that the plane is flying due east. So due east at a speed of 500 miles per hour. So I'm going to write that vector. That is the vector. I was going to call it V1. And since it's flying at 500 miles per hour east, so it'd be 500I, or if you can prefer component form, it would be 500, comma 0. Oops. Okay. And then the second vector that we're going to draw is the tailwind that it says. So as a tailwind of 70 miles per hour in the direction of 30 degrees east of north. So that means my wind is going this way. So 30 degrees east of north, which means this angle here is actually 60 degrees. And I'm going to call that V2. And it says that the speed of that is 70. So we did this last year by saying 70, and then we did cosine of 60I plus sine of 60J. Okay. And then I'm just going to multiply the 70 by into this. So that ends up with 35I plus 35 root 3J. Okay, and then the actual speed and direction is now going to be the blue line. So we're going to call that the resultant vector. So the result vector comes from adding the two vectors together. So I'm going to do 500 plus 35. I get 535I. There is no j, so then this stays the same. So 35 root 3j. And I need the magnitude of this thing to find the actual speed. So the magnitude will be the speed. And I'm going to trust that you guys can figure this out in your calculator as the Pythagorean theorem, right? So when I put this in my calculator, I believe I get 535.1 miles per hour. So that's the actual speed. Then I need to figure out the direction, right? So the direction is actually the angle that and remember this is in bearing, so it's the angle that the plane is making off of the y-axis. So it'll be north towards the east. I just have to figure out what it is. So you have a couple of choices on how to do this. I think the best way to do it is you're going to use your cosine theta formula that we just learned. So dotting and then magnitudes. But the two vectors I'm going to use are going to be the blue vector, which is the result vector, and then this vector in the j direction here, right here, 1j. All right, so when I do the dot product of the result vector and the j1j vector, I get 35 root 3. And then in the denominator, it's going to be the magnitude of the result vector multiplied by the magnitude of the j vector. Well, that's just going to be 1. And then the magnitude we found was 535.1. So I am going to put that in my calculator. And 35 root 3 divided by 535.1. And my angle that I get is 83. So theta is equal to 83.495 degrees, and this is from the north to the east. All right, hope that makes sense. Make sure you ask me any questions or ask your teacher any questions tomorrow in class.